Hi everyone, in today's video, I'm going to show you how to find the equation of tangent line to a curve at a given point. In this question, we are asked to find the equation of tangent line to the graph of the function y equals 2x plus 1 raised to the power of 6 at x equals minus 1. Now to find the equation of tangent line, we might want to recall the point slope formula. The point slope formula is given as this: y minus y1 to be equals to m into x minus x1, meaning that if you want to find the equation of a straight line given a point and a slope, we can use this formula to determine the equation of a line. Now don't forget that we want to find the equation of tangent line, meaning that if we are able to get the slope of the tangent line, we can therefore use this point slope formula to find the equation of a line. Now here, m here is known as the slope. Slope is also known as the derivative of y with respect to x at point x equals minus 1. So this is the slope at point x equals minus 1. Now how do we find the slope at point x equals minus 1? For us to find the derivative of this function, we might want to use the chain rule. So to use the chain rule, let u be equals to 2x plus 1. That means that y is going to be u raised to the power 6. Now to differentiate y with respect to x, now since y is a function of u, so that means if we are to use the chain rule, we differentiate y with respect to u first, and then we go ahead and differentiate u with respect to x. So if we differentiate u with respect to x, so here we're given u to be equals to 2x plus 1. So if you differentiate u with respect to x, that means you have this to be 2. Since y equals u raised to the power 6, that means if you differentiate y with respect to u, so you're going to have this to be 6 u raised to the power 5 using the power law. So that means that the derivative of y with respect to x is going to be using this chain rule here. That means we're going to have this to be dy with respect to u is 6u. Now don't forget that your u is 2x plus 1. That means if you replace it back, that means you're going to have this to be 2x plus 1 to the power of 5. And then you have dx, du dx. So du dx is 2. That is the derivative of u with respect to x. And now we now have the derivative of y with respect to x. So we can combine the result and say, okay, the dy dx is going to be 12, because 6 times 2 is 12. And then we have 2x plus 1 raised to the power 5. Now this is the derivative of this function at any point x. Now, since we are interested in finding the derivative at point x equals minus 1, so to do that, all we have to do is just to substitute x, or we replace x with minus 1. So if we do that, that means we're going to have this to be 12 multiplied by 2 times minus 1, then plus 1 raised to the power 5. So meaning that if we simplify this, so this is 2 multiplied by minus 1 is minus 2. Minus 2 plus 1 would give us minus 1. So meaning that this is going to be 12 multiplied by minus 1 raised to the power 5. So this is the slope at this point, at point x equals minus 1. So meaning that our m here is indeed 12 multiplied by minus 1 raised to the power 5, which is minus 1, which is just minus 12. We have the slope. How do we determine the point? Now here, we are given x to be minus 1. Okay, how do we determine the corresponding value of y? We can just use this equation to determine the corresponding value of y. We're going to have this to be y to be equals to, so if you replace x with minus 1 here, so that means we're going to have this to be 2 into minus 1 plus 1 raised to the power 6. And here you end up having 2 multiplied by minus 1 is minus 2, then plus 1, that is minus 1 raised to the power 6. And minus 1 raised to the power 6 is 1, meaning that at point x equals minus 1, y is 1. So we have the point, and we also have the slope. So the slope here is what? Minus 12. So we can therefore go ahead and use the point slope formula. In this case, we are going to have this to be y minus y1. Here is like x1, and this is y1. So if we do that, so that means we're going to have this to be y minus y1 to be equals to slope, which is minus 12 multiplied by x minus x1. So x minus x1. So this is going to give us minus of minus 1. And then we go ahead and simplify this, which is minus 12x plus 1. And then if we simplify this, we can still have this to be y minus 1 to be equals to minus 12x minus 12. And then if we add 1 to both sides, that means we're going to have this to be y to be equals to minus 12x minus 12 plus 1, which is going to give us minus 11. Therefore, the equation of tangent line to this curve here is indeed y equals minus 12x minus 11. The slope being minus 12 gives us an idea that the slope here is going to be negative, right? So meaning that you're going to have a slope that is slanting this way. Alright, I hope you now know how to find the equation of tangent line to a curve at a particular point. And how do you do that? First of all, you take the derivative of the function to find the slope at that particular point by substituting the x point. Then after that, you find the corresponding value of y at the given point. You can now go ahead and use your point slope formula. So if you enjoyed this video, make sure you click on the like button and also on the subscribe button so that you'll be notified whenever I upload a video like this. See you in the next video.